Good afternoon, everyone, and welcome to MOS Live. My name is Katie, my pronouns are she, hers, and I'll be keeping an eye out for all of your predictions or questions about marker chemistry today. If you're watching on Facebook, please know that to make those predictions or type those questions to us, you're going to have to click on the Zoom link in the caption of this video. Once you're on Zoom, press the Q&A button to ask us a question. If you want to include your name and age, we'll try and give you a shout out if we can get to it. If you'd like to see captions, you can click on the closed captions button at the bottom of your screen and select show captions. So at this point, I'm going to invite my presenter to turn on their camera and introduce themselves.
Okay. Hello, everyone. My name is Zoe. My pronouns are she and her, and I work in live presentations at the museum, which means I am usually up on our stages. But my background is in chemistry and art, and so I am really thrilled to come here today and talk to you about some of the chemistry behind markers. All right, now I want to start out by just pointing out that not all markers are the same, right? I mean, it's a big difference between if I write on my hand with a washable marker or if I write on my hand with a permanent marker. Those are two different situations. So let's go ahead and explore some of the differences between those markers. Why are they different? And why is it kind of useful to know about those? Now, we're going to start out by looking at this piece of glass. You can see that I have written some letters on my piece of glass using different markers. I've got W, P, and D. The W stands for washable. This is a washable marker. P is permanent, and D is dry erase. So those are the three kinds of markers we're going to be focusing on today. Washable, permanent, dry erase. Now I'm going to go ahead and put this marker, or excuse me, this glass, into a picture frame. That way I can stand it up and everyone can see it a little better. And we're going to do a couple of little tests just to get a good look at what exactly the difference between these markers is. The first test I'm going to do is just take these cotton balls and gently rubbing it across the glass. And, you know, a really important thing for scientists to do is make predictions based off their prior knowledge. So audience, maybe I can get some predictions from you. Which of these three markers do you think would be affected by me rubbing the cotton ball across the glass?
All right, predictions are coming in. I'm seeing predictions for the dry erase marker. Okay, yeah, maybe some of you have used dry erase markers in classrooms or places like that. And maybe you know a little bit about how they act. Let's go ahead and see if we're right. Absolutely. The washable marker and the permanent marker did not budge, but the dry erase marker is gone. All right. Now I'm going to do one more test, and I'm really going to do the exact same thing. I'm just going to change one little detail. I'm going to get this cotton ball wet, just with a little bit of water from my sink. And we're going to rub this cotton ball over the glass again. Now, do you think, audience, based on your prior experience, do you think this would affect the washable marker or the permanent marker? What are our predictions? Lots of washable marker predictions coming in.
All right, let's go ahead and try that out. Here's our water. Oh yeah. So you are spot on. The washable marker is gone. The permanent marker is not going anywhere. All right. So that's a pretty big difference with just some tiny little changes. If we want to understand why these three markers act so differently, we're going to have to think about what marker ink is really made of. So let me go ahead and pull up an image for us to look at. Okay. Now, marker ink has two main parts to it that we can think about. You've got the liquid part of the ink, which is usually water or some kind of alcohol. And then you've also got the stuff that's dissolved into that liquid. Now that can include things like the pigments. Those are the things that give the marker its color. It also includes resins, which help the ink smooth out and have a good texture and also stick to the surface you're writing on, in this case, my glass. And there could also be a few other things dissolved into that liquid. For example, maybe something that would help the marker stop from drying out. So those are the those are the sort of things that would be dissolved into our liquid. Now, when you go ahead and write with the marker, well, you need the marker ink to be a liquid in order to write with it, right? Otherwise, it won't come out of the marker at all. But after you've written whatever you've written down, then the liquid is actually going to evaporate away. That is what happens when the marker ink dries out. And left behind is just going to be all that stuff that was previously dissolved into the liquid, pigments, resins, etc. All right, well, that means that when we are looking at my glass picture frame, then the stuff we're trying to get rid of is just the stuff that was formerly dissolved in the liquid. This actually explains the difference between those washable markers and the permanent markers. See, the washable marker is a water-based marker. So when I write with it, all of this stuff that's left behind on the glass had to have been dissolved in water, all right? Now that means, I guess it kind of makes sense that we can use water to dissolve it once again. All we have to do is get it wet, and all of those solid pieces dissolve and disappear. All right. Now, the permanent marker is not water-based, hence why water does not dissolve any of that stuff. The permanent marker is an alcohol-based marker. So maybe it would make sense then that you need alcohol to get rid of this permanent marker. Or do you? Audience, do you maybe know any tips and tricks you've picked up over the years? Maybe things you've heard? How do you get rid of permanent marker? Any suggestions?
Oof, it's a tough one. Answers are a little bit slower. Some people have tried soap and water, but we also have various kinds of liquids that I think actually have alcohol in them. So we have alcohol, rubbing alcohol, hand sanitizer. Somebody has also drawn over it with a dry erase marker and then erased both of them off.
Good, good. All right, I'm hearing a lot of good tips. So Katie's right that a lot of these suggestions make a lot of sense because things like rubbing alcohol or hand sanitizer do have alcohol in them. So that makes perfect sense that those could get rid of an alcohol-based marker. But another thing that I really like to use is hand sanitizer. Now, excuse me, I just said hand sanitizer. I meant nail polish remover. Nail polish remover is not made of alcohol. It's made of acetone or something similar to acetone, but acetone is pretty similar to alcohol, at least in the ways that count. Don't drink it. But it's chemically similar enough for this to work. As you can see, if I have my acetone on this cotton ball, then that permanent marker is gone, just like that, easily dissolved away. So alcohol or something containing alcohol or something similar to alcohol, all of those things will work to get rid of that permanent marker. All right, now this kind of brings us to the dry erase marker, right? Because when I got rid of that letter D, I wasn't using any liquids to dissolve anything. All I had to do was just wipe it away. So what's the deal with that? Well, dry erase markers are kind of special because they have an extra ingredient in them that's called a separating agent. Now, a separating agent helps to separate the ink from a smooth surface. That's all it really does. It just makes the ink kind of slippery so you can wipe it away. But if there wasn't a separating agent in here, or if you wrote on something that isn't smooth, like something like a piece of paper, a piece of fabric, paper towel, well then the separating agent doesn't do its job and this dry erase marker actually starts to act almost exactly like one of the other kinds of markers. So audience, do you have any predictions? Do you think that the dry erase marker is almost exactly like a permanent marker or a washable marker when the separating agent fails?
Oof, it is pretty much an even split between, I think maybe there's slightly more permanence than washables.
Okay. So we're not entirely sure, and I do love when we've got some good debate going on because that means we can really get down to the nitty-gritty and test this out. So I'm gonna go ahead and add some water to this paper towel. Now, you might already have an idea of what happens to the washable ink and the permanent ink when we get them wet. Based on our previous experiments, the washable ink is spreading out because it's dissolving. And the permanent ink, when we get it wet, doesn't spread out at all. It doesn't go anywhere because, again, washable markers are water-based, permanent markers not water-based. All right, now let's go ahead and figure out where the dry erase marker lands in all of this. Looks like that ink is not spreading out at all. So a dry erase marker is alcohol-based. It is almost exactly the same as a permanent marker when you write on something that isn't smooth. So if you're going to be writing on your hands anytime soon, maybe don't pick the dry erase marker. But yeah, you know, someone earlier mentioned that you can use dry erase marker to write over top of a permanent marker and then wipe the permanent marker away. That was a really great observation, and that's because the dry erase marker has some alcohol in the ink. As long as the ink is still wet, it can dissolve the permanent marker. One other clue that might help you realize that they are the same is because they both smell kind of questionable, right? When you smell that weird smell from a permanent marker or a dry erase marker, that's the alcohol that's evaporating and reaching your nose. Okay, great. Now that's all pretty interesting. I think it's pretty fun, but what's the point? Why do we care about these differences? Well, we can use them in a few different ways. So, for example, what if you have a marker and you're not sure what kind of marker it is? This one that I had in my house, it doesn't say washable on it. It doesn't say permanent. It doesn't say water-based or alcohol-based. So how do I know what I should use it for and what I shouldn't use it for? Well, we can do a test. So I'm going to go ahead and lower my camera here so you can see this little glass bowl. Now, my little glass bowl has our letters written on it. We've got P for permanent, W for washable, D for dry erase. It's actually in red this time, and you might see why in just a little bit. But our mystery marker is the M right down here. I am going to go ahead and pour some water into this dish, and I'll ask you, the audience, to make some observations about what you see. You can go ahead and type those observations into the Q&A box. All right. Swirl that water around a little bit. Any observations?
We have that the washable marker dissolved. I like this term, the dry erase marker peeled away.
Yeah,
so there's still some particles there.
All right.
And water turns slightly blue. Some great observations.
Wonderful. All right. And what do we think as far as our conclusion goes? I mean, the washable marker dissolved. That makes sense. It's water-based. The two alcohol-based markers did not dissolve, but the separating agent made the dry erase marker peel up and float on the surface. What do we conclude about my mystery marker? What kind of marker is it?
There's lots of predictions that the mystery marker must be permanent, or at least more permanent than the other two.
Yeah, I think that's a really, really great answer. We don't know 100% for sure if it's a permanent marker. Maybe there's some other kinds of alcohol-based markers out there, but I would say it's probably alcohol-based, maybe permanent. It's a really great conclusion. All right. So now we know a way that we can solve some little mysteries, but I was really interested by the fact that that dry erase marker can peel up and float on the surface of the water. So another thing we can do with our newfound knowledge about markers is a fun little activity with dry erase markers. I'm gonna lower you back down. Now I've got a different piece of glass. This is actually from my butter dish, but any piece of glass that's kind of flat like this with edges on the sides will work really well. Now I am going to go ahead and draw some things that I want to float in the water. So I'm going to draw a stick figure, and maybe I'll give my stick figure some fish. Maybe we can make all of these fish and the stick figure swim around with each other. Again, this is going to work because The dry erase marker has that separating agent, and it's alcohol-based. So 1, it doesn't dissolve in the water, and 2, it can lift away from the glass. Now I have to gently pour the water kind of far away from the marker. If you pour it too close, then the marker might kind of crumble up into a weird blob. And that can be pretty funny, but let's see if I can get them to stay in the shape that they are right now. All right, we've got one fish. It looks like my person is out here. The other fish is a little bit stubborn, huh? But maybe if I swirl this water around a little, that fish, whoops, a little too much force, but hey, now we've got a little blob to swim to. All right. So if you would like to make your own floating drawings, this is pretty easy, right? All you need is a piece of glass, preferably something with edges to catch the water, and a dry erase marker. And if you want to keep your swimming drawings after the fact, then what I would recommend doing is go ahead and try this out. I've got a piece of paper here that I'm going to gently press to the surface of the water. We'll see if it works. Oh, there's my drawings on the piece of paper, see? You just want to be careful with them because after the fact, you can kind of rub them away if you're a little violent. All right, very cool. Now, speaking of keeping your drawings and your artwork, I think the last thing I want to mention as far as activities go is, of course, we can use markers to make art, right? That's one of the best things about markers. So I've got a little art activity to show you guys that you can do at home if you've got both washable and permanent markers on hand. Now, there's a few different ways that you could try these activities. So I'm going to show you 2 things that I was able to do using these different kinds of markers. All right, the first one involves a really thin piece of paper. I used a coffee filter, but something like a paper towel or a napkin might also work. Now, I went ahead and drew some letters and some stars with a black permanent marker. And I know that this black permanent marker is not going to be affected by water. But I went ahead and made a bunch of scribbles with a bunch of colors with washable markers. So now when I spray this with water, all of those washable markers are going to spread out through that thin piece of paper and the permanent marker will stay put. That's pretty cool. Now the important part here is that you gotta let it dry because when you dissolve all of that ink is gonna go everywhere. If you touch it while it's wet, it will go all over your fingers. Trust me, I speak from experience. And it will also go everywhere underneath it. So if you put down a blank piece of paper, then when you peel up your design, you will actually have a second piece of art there. I think that's pretty cool. You can get 2 pieces of art for the price of 1. Okay, so that's using the thin paper. If you're the kind of person though that doesn't want your colors to go everywhere and make a big tie-dye mess, maybe you want a little bit more control, then in that case, I have a second option for you. Maybe you can use a thicker paper that will catch the water, keep it from spreading everywhere, and you can put the water only in specific places. In this case, I'm drawing a tree, and I put the branches in permanent marker because I wanted them to stay put. But all of the other colors are washable. And then I used a paintbrush to add water just to those washable areas to help the color spread out. That way, you get kind of a nice wash. So if you've ever wanted to try watercolor painting, but you don't have watercolors at home, you might be able to try this. It's kind of similar. All right. Now, one thing that scientists and artists have in common is that both scientists and artists love to experiment. So I showed you 2 ways that you could do an art project. I would really encourage you to mess around with different kinds of paper, different kinds of markers, or things that aren't markers. Pencils, crayons, whatever you want. See what kind of art that you can create using these different materials. All right, now it looks like that is all I have for activities. So do we have any questions in the chat that I can answer, Katie?
Zoe, you actually got all the questions, I think, right there. We have a whole bunch of questions about different variables that people could test at points. So I'll list some of them. So for getting permanent marker off, we have some suggestions of lemon juice, shaving cream, one of those magic erasers from the store, and a couple hairsprays, which I think would be interesting to try. And for the floating people experiment, we have maybe could a plastic container work in addition to a glass container? Could foil work during different parts of this? So yeah, I think some awesome materials to try out.
Those are really interesting questions. And I do hesitate to use plastic for the floating one. It might work just fine. I haven't experimented with it too much myself because I don't have a ton of plastic containers sitting around that I don't use for food. But I would definitely encourage you to try it with plastic that you're maybe not as attached to. The only thing that I worry about is that plastic can sometimes break down a little more easily than glass. So it might not be quite as good as glass is, but I'm tempted to say that it would work. You just want to be careful about trying to clean markers off of plastic because, like I said, the plastic can break down more easily than the glass can. So I probably wouldn't try putting nail polish remover on plastic, but glass is probably fine. All right. Any other questions that have popped up?
Yeah, I think that actually leads into a great observation about how abrasive some alcohol cleaners can be and how maybe that's why it works on permanent marker. But we also have some questions about the kinds of alcohol that would be in the markers or in these cleaners. Could you talk a little bit about that?
Yeah, so there's a few different kinds of alcohol that can be used in these sorts of markers. I think that the stuff in Sharpie is largely ethanol, which is the same kind of alcohol that you would get in an alcoholic drink. It's denatured ethanol though, which means that it's not going to taste good. And there's a bunch of other stuff mixed in there anyways, so you really wouldn't want to try and ever drink Sharpie ink. Bad idea. But you might also have things like propanol or butanol. These are molecules that are kind of similar to ethanol, just slightly different. Maybe just slightly larger. And there are actually permanent markers that are not alcohol based. So there are permanent markers that are like very strong, the ones that smell really terrible, that might have other kinds of molecules in them that are even stronger than alcohol. The only thing is those molecules can be toxic. So those markers are not as common anymore, and most of them just use alcohol instead. Just want to point that out in case you ever find a really strong, heavy-duty permanent marker. Probably don't stick it up to your nose and smell it. Those chemicals can be bad for you.
Thank you, Zoe, getting into all sorts of levels of chemistry here today.
Absolutely.
I think that's all we have for the questions, actually.
Okay.
So I'm going to invite you to say goodbye until next time.
All right. Well, thank you very much. And if anyone makes any cool pieces of art that they want to share with what they used today, please do tag us on social media. I would love to see them. So with that, I'll hand it over to Katie. I think she can tell you a hashtag you can use.
Thanks so much, Zoe. And thank you all for joining us today and being amazing scientists. I had over 325 questions and predictions and comments, so I'm really sorry if I didn't get your name or I didn't get to respond, but we look forward to seeing you next time. And as Zoe mentioned, I have some hashtags to share with you. All right. So thank you for joining. To check out more programs, visit the website mos.org/mosathome or follow us on social media. And while you're following us on social media, you can use this hashtag #MOSAtHome to share how your experiments with marker chemistry went. Thanks everyone. Enjoy the rest of your day and we'll see you next time.